I'm Ehashanul Akter. Our topic is binary search tree, and I'm talking about search node and delete node. Search node. The left subtree of a node contains only nodes with keys lesser than the node's key. The right subtree of a node contains only nodes with keys greater than the node's key. The left and right subtree each must also be a binary search tree. There must be no duplicate nodes. This is the binary search tree. Before searching a node, let's see the search algorithm. Compare the element with the root of the tree. Number 2. If the item is matched, then return the location of the node. Number 3. Otherwise, check if item is less than the element present on root. If so, then move to the left subtree. Number 4. If not, then move to the right subtree. Number 5. Repeat this procedure recursively until match found. Number 6. If element is not found, then return null. Let's find 23 from nodes. 25 is the root node. We know that lower node than root node goes left side and bigger node than root node goes right side. So we need to go left side because 23 is lower than 25. 15 is root node now. 23 is bigger than 15. So we need to go right side. Yeah, we found 23. Now let's talk about deleting node. Let's see the delete algorithm. Number 1. Starting at root, find the deepest and rightmost node in binary tree and node which we want to delete. Number 2. Replace the deepest rightmost node's data with node to be deleted. Number 3. Delete the deepest rightmost node. Now see an example. Let's delete 23 from nodes. Here 22 is less than 23 and 18 is less than 22. So if we delete 23 from node, 23 becomes 22 in nodes. Again 18 comes into 22. Like this. Now this is the tree after deleting 23 from node. Thank you very much.
Hello everyone, I am Habibur Rahaman Fahim and my topic was about tree traversals, which is generally in order, pre-order and post-order. Order relation. Traversal is a process to visit all the nodes of a tree and may print their values too, because all nodes are connected via edges. We always start from the root node. That is, we cannot randomly access a node in a tree. There are three ways which we use to traverse a tree. First of all comes in-order traversals, then pre-order traversals, and finally post-order traversals. Generally, we traverse a tree to search or locate a given item or key in the tree or to print all the values it contains. Here we can see an example of a binary search tree. First of all, here we can see the root node containing value 25. There are some nodes in the right side and also in the left side. All these nodes containing some specific values. In-order traversal. In this traversal method, the left subtree is visited first, then the root, and later the right subtree. We should always remember that every node may represent a subtree itself. If a binary tree is traversed in order, the output will produce sorted key values in an ascending order. So in order, visits nodes in the following order. First of all comes 4, the upper node 10, then again goes to the lower node 12, then comes 15, then 18, then 22, then 24, and here it comes the root node containing value 25, then again goes to the lowest node from the right side, which is 31, then 35, then 44, then 50, 66, 70, and finally 90. Period traversal. In this traversal method, the root node is visited first, then the left subtree, and finally the right subtree. So, period traversal visits nodes in the following order. First of all comes the root node, which is 25, then comes 15, 10, then it goes to the lowest part of the left node, which is 4, then 12, then 22, then 18, 24, then it goes to the right side 50, 35, 31, 44, 70, 66, and finally 90. Post-order traversal. In this traversal method, the root node is visited last. Hence the name. First we traverse the left subtree, then the right subtree, and finally the root node. So a post-order traversal visits nodes in the following order. First of all comes the lowest part from the left subtree, which is 4, then 12, then 10, then 18, then 24, 22, 15, 31, 44, 35, 66, 90, 70, 50, and finally it comes the root node, which is 25. So these are the way how tree traversals actually work. Thank you.
My name is Shadman Shariar. Today I will discuss about how to create a binary search tree from some keys. Here we have some keys. So if you want to create a binary search tree from keys, you have to follow these two rules. Number one is parent node less than right child node, and number two is parent node greater than left child node. Here we have some keys. Our first key is 25. I am going to add 25 first. So 25 will be the root node of our binary search tree. So here I added 25. Our next element is 50. 50 is greater than 25. So 50 will locate it on right from 25. This node will locate it on right from 25 because 25 is less than 50 and 50 is greater than 25. Our next element is 15. 50 15 is less than 25, so 15 will locate it on left from 25. 15 node will locate it left from 25. Our next element is 22. Here 22 will compare first with 25. 25 22 is less than 25, so it will go left. Then 22 will compare with this 15 node. Obviously 25 is greater than 15, so it will locate it on right from 15. Our next element is 10. So here 10 will compare with 25. Obviously 10 is less than 25. That's why 10 will go left. Then 10 will compare with 15. Obviously 10 also less than from 15. So 10 will locate it on left from 15. So this node will comparing with 25 and 15 and located on left from 15. Our next element is 35. Here 35 will compare with 25 greater than 25 right and less than 50. So 35 will located on left from 50. Our next element is 70. So 70 will compare with 25 greater than 25 greater than 50. So it will located on right from 50. Our next element is 4. So 4 will compare with 25, then 15, then 10. So 4 obviously less than 10. That's why 4 will be located on left from 10. Our next element is 20. So 20 will compare with 25, less than 25, less than 50 and greater than 10. So 12 will located on right from 10. Our next element is 24. 24 at first will compare with 25 less than 25 greater than 15 and greater than 22. So it will located on right from 22. Now I am going to add 18. 18 is our next element. So 18 will compare with 25 less than 25 go left, greater than 15 go right, less than 22. So 18 will located on left from 22. Our next element is 44. So 44 will compare with 25 greater than 25, 25 then 50 and at last 35. 35 and 44 will located on right from 35 because 44 is greater than 35. Our next element is 31. So 31 will compare with 25 greater than 25 will compare with 50 then 35. 31 is less than 35, so 31 will located on left from 35. Our next element is 66. So 66 will compare with 25 first, greater than 25 go right, greater than 50 go right and less than 70. So 66 will located on left from 70. Our last element is 90. 90 will compare with 25 greater than 25 go right, greater than 50 go right and greater than also 70 go right. That's why 90 will located on right from 70. Here we created a binary search tree from these keys. Here the another thing is, if you want to add another element in this binary search tree, then this element will located at the end. So if you want to add 60 in this binary search tree, then 60 at first 60 will compare with 25. 60 is greater than 25, so 60 will go right. So then 60 will compare with 50. Obviously 50 is 60 is greater than 50, so 60 will go right. Then 60 will compare with 70 to 70. 60 obviously less than 70, so 60 will go left. At last 60 will compare with 66. 60 obviously less than 66, so 60 will located on the left from 66. Here 60, this node comparing 25 greater than 25 go right, greater than 50 go right, less than 70 go left and less than 66 go left. If you want to add another element 78, then this element also will located at the end. If you want to add 78, 78 will compare with 25 first. 78 is greater than 25, so 78 will go right, then 78 will compare with 50. 78 also greater than 50, so 78 will go right, then 78 will compare with 70. 78 also greater than 70, so 78 this time 78 will go right. and at least 78 less than 90. So 78 we look at it on the left from 90. 78 at first comparing with 25, then go right. 50 greater than 50 go right, greater than 70 go right, and less than 90 go left. So if you want to add another element in a binary search tree, then it will be located at the end. So thanks for watching my video. Goodbye.